Hello, welcome everybody. Here is how you do problem number 3 on the 2015 BC calculus exam. So first of all, this is a classic table problem. If you take a look at it, the table is given and it's about Joanna jogging along a straight path. Joanna's velocity is given in the table above, and the velocity is, the time is measured in minutes and the velocity is in meters per minute. So the first question is estimate the value of v prime of 16. Since 16 is smack dab in the middle between 20 and 12, all you have to do is use this interval right here to estimate its slope, and that's what v prime is if this is a table of v. So this is only worth 1 point, so all you need to do is have a correct answer. So all you need to do is have this answer right here, or you can certainly simplify it out to 5 if you want to. 1 point. Next part, part B. So part B says, Joanna jogged using the correct units, explain the meaning of the integral of the absolute value of the velocity problem, and then use a right-Riemann sum using 4 subintervals and estimate that. So let's start with the interpretation. What does this mean in the context of the problem? So anytime you do an integral of velocity, if the absolute values are not present, it's displacement. But since the absolute value is present, then it's total distance. So for the exclamation point, you need total distance. You also need meters because it says using correct units. So somewhere in your problem, you had to have said meters for this part. And you also need it over the time interval 0 to 40, because that integral is not 0 to 20, it's 0 to 40. So that does make a difference in your understanding of what that integral means. The second part is a right Riemann sum. Now I did a quick little analysis here of all these points and just threw them together. I almost always do this on a Riemann sum problem. And since it's a right Riemann sum, you're going to just basically go over and down. This would be like rectangle 1. And same thing here, over and down. This is rectangle 2. Now, since it is absolute value, this 24 negative 220 should actually kind of be up here to be positive 220. And then once again, you go over and down to get your other rectangle. And then your 40. So here are your 4 rectangles, and basically it's width times height. Now your height in this case, I'll highlight this in purple, is the right side of each rectangle. So if you notice, your right side of the first interval is what's happening at 12. So that's why it's going to be 12 across, and v of 12 is the height. Same thing for rectangle 2, 3, and 4. If you ever make a mistake on this, it's basically my recommendation is to just draw a picture. It takes a couple seconds, but it's well worth the understanding and the visualization of this problem. So for the right Riemann sum, that's basically this first part or second part. Now you really don't have to simplify it. So if you left it here, you're going to get the last 2 points. But if you do simplify it and you simplify it incorrectly, that's why they have this third point available for this one. So if you add wrong, you won't get deducted twice, you'll only get deducted once as long as you have this all worked out. So the bottom line is I wouldn't simplify it unless you're asked to or needed that answer in the second part. For part C, we got Bob now. Bob's a little different. He's riding a bicycle along the same path, and Bob's velocity isn't a table, it's a function. T is measured in minutes, and v of t is in meters per minute. So it's basically the same kind of problem. So if you're asked for acceleration at a time, that is definitely a derivative of v. So derivative of velocity gives you instantaneous acceleration. So if you knew to calculate v prime, anywhere on your paper you have v prime, it just says uses, that means you understood what to do, you get that first point. And then of course you need to kind of do the antiderivative and figure out the answer. This is an acceptable answer, unsimplified, and if you simplify it, that is also acceptable. If you wrote this and simplified it incorrectly, you wouldn't get that point. That's why it's best not to simplify these unless you have to get that second point. And then for the last part, part D, based on the model from C, find Bob's average velocity. I'm just going to go back for a second here. So if you're given velocity, like you are in part C, and you're asked for average velocity, you're staying at the same level. That's not a slope problem like it was in part A. This is an average value problem. So this is the entire piece for average value. How do you assign points? First point is for the integral only. So if you miss the 1/10 or divide by 10, that's okay, as long as you have an integral of b from part C. So that's the first one. Antiderivative is needed for this problem here. So raise the power, divide by 4, just power rule. So that's how you get your second point. And then your third point is the answer. Whether it's unsimplified or simplified, both are okay. The units in these last two are here to just guide you. Even if they're wrong, you're not going to get to the point because the question didn't say anywhere to indicate the units of measure like it did earlier in the problem. Thanks for listening, everybody. Good work.